Okay, good afternoon, students. Is my screen visible?
No,
No,
ma'am.
ma'am.
No, ma'am.
No, ma'am.
Okay, let me know once it is visible. I'm resharing my screen.
Ma'am, it's visible now.
Okay, thank you. Okay, last class we had talked about the complements. We had seen that there are two kinds of complements, namely the r's complement and the r minus 1's complement. So accordingly, for decimal number system, we have a tens complement and a nines complement. And for binary number system, we have a twos complement and a ones complement. Okay. Now, today, the first thing that we're going to see is we're going to talk about the subtraction of unsigned numbers. Okay. If you remember, the main motivation, one of the main motivations that I told you for discussing complements was that it helps in the subtraction of the numbers. So we don't have to follow our paper and pencil method, which is not very optimized when we implement it in the hardware. Okay, we can rather just convert subtraction into addition using complements. Okay, so there could be a single adder circuit. There could be a single adder circuit which performs not only addition but by this method that you are about to see using the complements, it can also perform subtraction. Okay, so we don't need two different circuits and we can perform the subtraction as easily as we can perform the addition. Okay. Other benefit of using complements, as I told you, was to do to be able to do certain kind of logical operations. So again, time and again, we will be revisiting this second advantage where you will see that we will be using the different type of complements. For example, one's complement is very often used for logical operations. Similarly is the two's complement. Okay. Today that today the topic that we're going to focus on is the subtraction of unsigned numbers. Okay. We will also see after a while how to deal with the signed numbers. That means how the signed numbers are represented and how to do binary arithmetic using signed numbers. But I want to focus your attention on the word unsigned. So what we are discussing today is how to perform subtraction of unsigned numbers. Okay, yeah. So somebody read for me? Who will
Yes,
volunteer
ma'am.
to read today?
I'm
Okay.
Garima.
What's your name, beta?
Garima.
Garima. Yeah, Garima.
The direct method of subtraction taught in elementary schools uses the borrow concept. In this method, we borrow a1 from a higher significant position when the minuend digit is smaller than the corresponding subtrahend digit. This seems to be easiest when people perform subtraction with paper and pencil. When subtraction is implemented with digital hardware, This method is found to be less efficient than the method that uses complements. Subtraction. The subtraction of two n-digit unsigned
So
numbers
this,
m.
just give me a second. So the motivation was clear, students?
Yes,
Is this
ma'am.
motivation
Yes,
clear?
ma'am.
Right? Okay.
Yes, ma'am.
Yeah. Now we are going to see the actual method for subtraction. Please read, Garima.
Subtraction. The subtraction of two n-digit unsigned numbers m minus n, where n is not equals to 0, in base r can be done as follows. First, add the minuend m to the r's complement of the subtrahend n. This performs m plus r raised to the power n minus n is equals to m minus n plus r raised to the power n.
So what is the first step? The first step is simply, if I want to do m minus n, please note that n cannot be 0. Okay. Now, if I want to subtract n from m, that is do m minus n, then what I do is I take r's complement. For example, if these numbers are in decimal number system, if these are decimal numbers, then we take tens complement of n. If these are binary numbers, then we take twos complement of n and add that complement to n. Okay? Yeah.
Second, if m is greater than or equal to n, the sum will produce an end carry r raised to the power n, which is discarded, and what is left is the result m minus n.
So if m is greater than n, okay, then the sum of m with n's complement will surely give us an end carry. Okay, and what do we have to do? We simply discard the end carry. The remaining number is our result. The remaining number will be our result of m minus n. Okay. Now let us see what happens in case m is less than n. Then what happens? Yeah.
If m is less than n, the sum does not produce an n carry and is equal to r raised to the power minus n minus m, which is the r's complement of n minus m. To obtain the answer in a familiar form, take the r's complement of the sum and place a negative sign in front.
Yeah. So what happens when this number m is less than n? In that case, please see this sum that we get of m plus r's complement of n will never produce an end carry. Okay. And that will be a signal for us to understand whether m was greater than n or m was less than equal to n. So in this case, what we do is we take the complement of the sum so obtained and place a negative sign before it. And that is our final result. And that is our final result. Is that clear?
Yes, ma'am.
Let us see this through some examples. Okay, so let us look at the first example, okay, of decimal numbers. So I just simply want to subtract 147 from 150. Okay, so all of us know that the answer should be
3.
yes.
3.
What will I do? Step one is to find tens complement of this number 147. Now, what would be the tens complement? Let me, if I just want to do it orally, please see, I'll first find out the nines complement of this, which will be
Triple
8,
nine.
5, 2
2.
plus
Yes,
1,
ma'am.
853. So tens complement is 853, right?
Yes,
Second
ma'am.
step is to add 150 to tens complement of 147. So what do I get? I get, we see, 3, 0, 1, then again 0 and an end carry of 1. What is the end carry? End carry means that if this is a 3-digit number, you can see, then the sum is also of 3 digits, then there is no end carry. But if there is an extra fourth digit produced in the leftmost bit, if there was a carry out of the last position, okay, then that is known as the end carry. So in this case, we see there is an end carry, right?
Yes, ma'am.
Yes.
Yes,
We
ma'am.
simply discard this, and what is the answer that we get?
003.
003, which should have been the answer. Is it okay?
Yes, ma'am.
Yes, ma'am.
Good. Let us see another example. Now, the same numbers, I have reversed their positions. Okay. So this time, again, I'm going to take the tens complement of the minuend. This time the minuend is 150. Right. So what would be the tens complement for 150? Let's work it out orally. 8, 4,
449.
9.
9. It would be 8, 4,
9.
9. Yeah. So the tens complement should be
850.
850.
plus 1, which is
850.
850.
850.
right 850, right? So we add 850 to this, right? And what do we get? 7 here, 9 here, and 9 here. Any problem up till now?
No, ma'am.
No, ma'am.
No, ma'am.
Do we get an end carry?
No, ma'am.
No,
No,
ma'am.
ma'am.
There is no end carry, right? So what do we do in this case? We again take the tens complement of this number, right? And
Excuse me, ma'am.
place a negative sign before it, right? Yes.
Ma'am, in this case, m is less than n. So हम टेंस कॉम्प्लीमेंट में +1 थोड़ी करेंगे.
बेटा आपकी ना आवाज ब्रेक हो रही है, फिर से बताइए.
Ma'am, actually, in this case, m is less than n.
यस.
So उसमें हम टेंस कॉम्प्लीमेंट में +1 थोड़ी ही करेंगे. लाइक सिर्फ टेंस कॉम्प्लीमेंट होगा ना, जो ऐड करेंगे हम पे.
जब हाँ, अगर ये छोटा होगा इससे, ठीक है, तो यहाँ तक तो उसका प्रोसीजर सेम है. These two steps are same. Okay. The only difference
मैम
will
ओके.
be that there will be no end carry here.
ओके मैम.
Okay. Now, since there is no end carry, then what do? I again take the tens complement of this result. Okay. What will be the tens complement of 997? It will be
003.
0, 0,
003.
right? And then we place a minus sign before it for our answer. So the answer becomes minus 003. Is this clear?
Yes, ma'am.
Yes, ma'am.
Right? Okay. So let us see if you can do a question yourself. So I've already done the tens complement. I showed you the tens complement of this number earlier on. Okay. In this slide in the last class. So I've purposefully kept the same number here as minuend. So I want you to perform this computation. Okay. Please don't look at the result. Just perform this computation. Try and do it yourself. I'll give you 2 minutes.
Done, ma'am.
Done, ma'am. Done, ma'am.
Okay. Let's wait for other people. Only 45 people have marked their attendance in theory. But it will be difficult for you later. Okay. Later, there nobody will entertain your request saying that I was present, I did not mark my attendance. Okay. And only 17 people have marked their attendance for B3. So please, I have requested you many times. I'm requesting you again. Do mark your attendance. Okay. Okay. So let us check what is the answer that you're getting.
98855.
Yeah. Okay, good. Okay. So we first take the tens complement of this number 456700. If you remember, we had computed it earlier. Remember? Right?
Yes,
Okay.
ma'am.
So
Yes.
53300 was the tens complement for this number, and I add this to our minuend. What do we get? We get this number, and we see that there is a end carry, right? We discard the end carry, and the remaining number is the result. You can also perform this subtraction on calculator to verify that your result is right. Okay. Not in the theory paper, obviously, but today you can verify, right? Now let us look at another example. Let us see if you can do this properly. So these are all fours. So 6 fours minus 456700.
Done, ma'am.
Done, ma'am.
Okay, what is your result?
I'm 12256
Minus
Again,
156.
minus 12256.
okay, let us do this together. So we again add the tens complement of this subtrahend to the minuend, gives us this. There is no end carry. Since there is no end carry, I must again take tens complement of this number, which is 0, 1, 2, 2, 5, 6, and for my final answer I must place a negative sign before it. Okay, so this is my final answer. Is this okay? Again, you can check this computation on the calculator. Any problem?
No,
Ma'am,
ma'am.
I think
No, ma'am.
Okay, we move on to the subtraction using 2's complement. So the method remains the same. The only difference is in the number system. So let us first perform the computation 1111 minus 1010. As you may recognize, this is 15 and this is 10, right? And this should be binary. So let us add the complement of 1010. Two's complement. Two's complement, how do we take? The digits up till the first one are copied as it is, and the remaining digits are reversed, right? So that gives me 0, 1, 1, 0. I add it to 1111, and what I get is 1 plus 0, 1, 1 plus 1, 2, which is 0, 1 carry. So 1 plus 1 plus 1, 3, which means 1 here and 1 carry again. And then 1, 0, 1, and then adding the carry, we get 2. So 0 here and a end carry, right? So there is a end carry. What to do? Simple. Discard the end carry. The remaining portion is the result. And what is the result? 0, 1, 0, 1. If you recognize, this is actually the
5.
equivalent of decimal number 5. So yes, 15 minus 10 is equal to 5, and this is the correct answer. Any problem?
No, ma'am.
no,
No, ma'am.
ma'am.
Good. I want you to do the reverse calculation now. So can you please try out 1010 minus 1111 yourself?
Done, ma'am.
Done, ma'am.
Done, ma'am.
Okay, what are you getting?
Minus 0, 1, 0, 1.
Minus 0, 1, 0.
Okay. Is everybody getting the same answer?
Yes, ma'am.
Ma'am,
Okay. So you can also see the working on the screen now. If anybody was stuck somewhere, then you know you could see. Any problem, bachche?
No, ma'am.
no, ma'am.
Okay,
No, ma'am.
good, good. So this completes this section 3.2 for us. I'm going to be sharing another PPT for the next section. So I want to do a couple of things. Okay, let me know when the screen is visible.
Visible, ma'am.
Good. Okay. So we are going to be talking next about in today's class. We'll start this and maybe follow up in the next class. We will be talking about the signed numbers, signed binary arithmetic, fixed point, and floating point representation. Okay. So first of all, what is fixed point representation? So please see, up till now we have not talked about any fractional numbers. Okay. Uh, how to represent a binary point. Binary point means a decimal, a point when we are using binary numbers, or a decimal point, simply the point when we are dealing with fractional decimal numbers, right? That is a big problem. Okay, how to deal with the point. So there are two types of representations. In the first representation, which is also known as the fixed point representation, the position of the point is fixed. It is either taken to be the leftmost, okay, or the rightmost. Okay, so if it is taken to be the leftmost, then obviously the entire number, as you can see in this example, becomes a fraction, right? Are you following?
Yes, ma'am.
Yes, ma'am.
And if we assume the rightmost position for the point, then the entire number becomes a integer. Okay. What is notable here is that this is not the exact or actual position of the point. That means that we are not physically storing the point anywhere. Okay, we are just assuming the position. So when if I assume that the decimal point will always be to the leftmost of a number, then I arrange all my numbers either by multiplying them by the powers of 10, if that's a decimal number or equivalent in the binary. Okay, so I multiply with the sufficient powers to get the point to this number, to this point. Okay, or I divide by, for example, if there were a decimal number, I would have divided by 10 raised to the power of whatever to get it in this form. Okay, so the fixed point representation assumes a fixed point for the decimal either on the leftmost side of a number or on the rightmost side of a number. We will see this other representation, which is called as the floating point representation. In and in there we will see that the decimal need not be, you know, uh, since the decimal since the position of the point need not be fixed in advance. Okay, uh, we don't need to actually modify our numbers in that case, in the floating point representation, to store them. Okay, so more about this later when we talked about when we talk about the floating point representation. The next thing that I'm going to discuss with you today is the signed numbers. Okay, so what we want to see here is how can we represent the sign of a number? Okay, so what we do is we reserve one bit, specifically the leftmost bit in a register, for for signifying the sign of that number. Okay. Now a 0 represents a positive sign and a 1 represents a negative sign. Always a 0 represents a positive number and a 1 represents a negative number. Okay. Now, for example, if I had a 8-bit register and I wanted to represent +5, then I wanted to store +5 in this register, then how would I have stored +5, the value of +5 in this register? So in the leftmost bit, obviously, because the number is positive, I would have put 0. And in this remaining bit positions, I store the magnitude of this number, that is 0, 0, 0, 0, 1, 0, 1. Is this clear to everybody?
Yes, ma'am.
Right.
Yes, ma'am.
Let's look at the negative numbers next. Now, please see, the simplest way to represent the negative numbers is that we just change the sign bit, because this is -5, so we just change the sign bit, and this is, as we all know, binary 5. Yes?
Yes, ma'am.
So this is known as the signed magnitude form for representing negative numbers. So we represent the sign and the actual magnitude of the number. Okay, so actual magnitude means the actual binary equivalent of this particular number, for example. Okay, now this sign magnitude form seems very simple to us. Okay, and therefore when we do binary arithmetic using pen and paper, we can definitely follow this, but it is not very preferred for computer arithmetic. Okay, so what we evolved was signed complement form. Signed complement form can take either of the two forms that you see here on the slide. So the first one being 1's complement form and the second one being 2's complement form. Okay. In the 1's complement form, what do we do? How do we get a number in the 1's complement form? We first write down its positive number, complete positive number along with its sign bit. Okay, we simply write that down for ourselves. Okay, now simply take 1's complement of this entire number, including the sign bit. Okay, so what will we get? 0, 1, 0, then all ones. 0, 1, 0, and then all ones. So automatically there is a 1 in the sign bit, and this is the 1's complement of this number. Is this clear? Now 1's
Yes, ma'am.
complement form is useful, as I told you earlier as well, for for doing a lot of logical operations. However, there is a very unique problem with 1's complement form, and I want you to try this yourself later after the class. How do you think would 1's complement form represent a 0? It would have different representations for +0 and -0. Although we know that there is no such concept of a +0 and -0, but it treats them as two different numbers in their own entirety. Why? Just because the just because the representation would be so different. Yes. So that's why we resort to the two's complement form for most of the cases when we are doing the uh, complement computations. Okay. So this two's complement form is the most widely used form for representing the negative numbers. And what do we do here? We simply take the 2's complement of plus 5 here. So if you are asked for 2's complement form representation of minus 5, then what you do is you first again write down the uh, representation for the positive 5, okay, and take the 2's complement of that representation. So what will you get? We leave the first bit that happens to be 1 this time as it is, and then invert all other bits. So what will I get? 1 1 1 1 1 0 1 1 1 1 1 0 1. This one, as I told you, is left as it is, right? Any problem?
No, ma'am.
No, ma'am.
Okay. So tomorrow or whatever is the whenever is our next class, that means we will be talking about uh, the arithmetic using the signed numbers. Okay. So I want you to go over very thoroughly with the topics that I've taught today. Okay. We have already taken the attendance, I think. Yeah, we've taken the attendance, right?
मैम एक्सक्यूज मी।
Yes, beta, tell me.
मैम मैंने उबंटू में मैम डाउनलोड किया सीपीयू सिम एंड हो भी गया। उसके बाद जब मैं उसे ओपन कर रही हूँ तो मैम टर्मिनल तो खुल रहा है, बट उसके बाद जो रिक्वायर्ड विंडो खुलनी चाहिए वो नहीं खुल रही।
उस पे एंटर दबा के देखना है।
मैम एंटर
ठीक है,
प्रेस करती हूँ तो नेक्स्ट लाइन में आ जाता है।
अब
उसमें आप वॉम्बैट लिख के देखना, फिर बैट
ओके
फाइल है ना
मैम।
उसमें, उसका नाम
या
लिख
मैम
के देखना।
ठीक है मैम।
Ma'am, वो fifth question.
या टेल मी।
Ma'am, you told me to remind you about fifth question of the assignment.
Oh yeah. Okay, yeah, thanks. Let me open that, huh? Do you have the screenshot of that question?
Yes.
Okay, I think I found it. Just give me a minute more. Okay, you share then.
Okay, ma'am.
Share your screen, please. Okay, so this was a question about the dual and a complement. I think that was the. So there is a difference between, I would like to tell everybody that there is a very small difference between a Boolean dual and a complement. Okay, so when we are required to find out dual, then we only need to replace the and sign with the or sign and the or sign with the and sign. Okay, and that's it. Okay, whereas when we need to take complement, for example, using the De Morgan's law of a Boolean expression, then the first step is to find the dual. Okay, and in the next step, we also complement each variable. Okay, so if you remember, when I said a dash, uh, let me see if I can find something to show you in this regard.
Ma'am, is my
Just a second. Yeah, yeah, tell me. Yeah, Dipali, yes, your screen is visible. Yes, your screen is visible. Yeah. So,
ma'am, I just want to confirm what's the answer of the question. It's either choice or section.
so the so accordingly, the correct dual for this would have been A or B. ठीक है? A or B in brackets. Then this gets reduced to, sorry, A dash or B dotted with A or B dotted with, I'm sorry, I'll just write it down somewhere. Okay, let me just put it in the chat window. That way it is easier for me to do as well. So it should be A dash. If we are just talking about the dual of this, then it should be A dash or B into A dash or B dash into B dash. This is it. So this is the dual. Okay. And if I am to find the complement, then we use the De Morgan's law. Okay. In that case, this answer that is given to you is right. So if we were to find complement, then after doing this, we would do the next step, that is change each variable to its complement form as well. So it will become A or B dash A or B into B. Okay. So since this answer is not mentioned here in any of the answers, so I will be giving you 1 marks. Okay, for this answer, even if you have marked it wrong, I will give you 1 mark. I will give everybody 1 mark for this
Thank you,
question.
ma'am.
Thank you,
Okay.
ma'am.
Thank you, ma'am.
Thank you, ma'am.
Okay, you're most welcome.
Thank you, ma'am.
Okay, good afternoon.
Good afternoon.
Good afternoon.